Hi and welcome to my video. This is going to be a video on rate of change. So under our main idea here, we're going to write the words rate of change. And we're going to talk just a little bit about it for a second. There isn't a great definition on the internet for rate of change, so I wanted to give you a definition that is more of a mathematical definition. So in the top box of here, we're going to write the definition. Definition is the ratio of the change in the dependent variable to the change in the independent variable. Ratio of the change in the dependent variable to the change in the independent variable. Right, so that's our definition. It's a math definition of rate of change. Rate of change is used in science and math and physics. So there's lots of different ways of looking at it, but here's a more mathematical way of looking at it. And so there's two ways that we can think of it, two like formulas, I guess you could call it. Since it's a ratio, that means it's a fraction. And so that fraction is the change in the dependent variable over the change in the independent variable. Our dependent variable is y, so it's the change in y over the change in x. This triangle is the Greek symbol delta, and it means change. So you might see that in science used for change in temperature, but in math we use it for change in y over change in x. And so on the other side, the left side of the main idea, we're going to do the same thing, but we're going to write change in dependent over change in independent. So change in dependent over change in independent. So a ratio we want to think of as a fraction. We've seen it in many other ways in middle school with colons, like 2:3, 2/3, 2 out of 3. But this is the way we're going to write the ratio when we're talking about a rate of change. And then you've definitely seen this before, but we are able to look at rate of change on a graph, and that is what we call rise over run. I know you've heard that before. Rise is our y, so change in y is our rise, so that's our up. How much is it moving up, or how much is it moving down? If it's a fall, not really a rise. And then our run is how much we move to the side. So that's our x. Our x always goes this direction, so that's our independent variable, so that goes in the denominator. And then our independent variable goes in the denominator. That's our x going left to right on the horizontal axis. And then our dependent variable is our y going in the vertical direction, is our y-axis. So rise over run is the same thing as rate of change. This is more of something we use when we're looking at a graph, but change in y over change in x can be used in so many different ways. It can be used on a graph, in a table, in a word problem with two ordered pairs, so it can be used in so many different places. It doesn't have just one use, whereas rise over run is typically for a graph. So we can write here, used on a graph. And then one last thing I want you to add here is rate of change is another way that we describe something that you've heard of a million times, that S word that you've heard so many times. So I'm going to box in the word rate here. The rate of change is often what we mean when we talk about the word slope. So what we mean when we say slope. So slope refers to a line, which then we think of a graph, but we can also think of it between points in a table. So many different uses for it. So remember, rate of change is the ratio of the change in the dependent variable to the change in the independent variable. We write it as a fraction. We use this delta y over delta x, which just means change in y over change in x. So go ahead and glue this into your notebook, and then you can move on to the next step. Thanks for watching.